Hi, future doctors. Welcome to the next class. In this class, we will discuss about cells connected in parallel. Cells in parallel combination. So, always parallel combination is nothing but one end is connected to one point. See, EMF E1, internal resistance R1. Internal resistance R2, EMF R2 means E2. So, both the positive ends, both the negative ends connected to a point A, B. Now, what is the effective EMF formula? Now, effective combination, I am taking it as like this. R equivalent, E equivalent. This is A, B. So, let us assume this is sending I current with this. This is going to be I. Now, in this cell E1, I am taking it as I1. In this cell E2, I am taking it as I2. Always current starts from positive, ends at negative. Therefore, I2. So by combining these two, I am taking this is I. Now, according to terminal voltage formula, VAB, that is V is equal to voltage across AB for E1. What is the formula we wrote? E minus IR. Therefore, I am writing VAB is equal to what we can write? E1 minus I R1. Correct? Like that, VAB for second step, E2 minus I R2. Correct? Two formulas we wrote. Next, what will be here? VAB is equal to, if you observe here, E equivalent minus I into R equivalent. Now, what is same among all these means? This is going to be I1, this is going to be I2, this is going to be I2. This is according to this formula we have. Now, what is same according to all the means? VAB, VAB, VAB. Therefore, from this equation, you can try to write I1, I2 because from the diagram, I is going to be equal to I1 plus I2. So voltage is same whenever capacitors, resistors, cells connected in parallel. So now we should calculate I1, I2 from this equation. So from this equation, VAB is equal to E1 minus I1 R1. I1 R1 is equal to E1 minus VAB. So I1 is equal to E1 minus VAB by R1. Same like that. I2 is equal to E2 minus VAB by R2. Substitute these two in this equation number 1. So I is equal to I1 plus I2. I is equal to. Now what we wrote here? In previous slide, what is I1? E1 minus VAB by R1. E1 minus VAB by R1 plus E2 minus VAB by R2. So expand this. E1 by R1 minus VAB by R1. E2 by R2 minus VAB by R2. So E1 by R1 plus E2 by R2 minus VAB comma 1 by R1 plus 1 by R2. So all these are going to be equal to I. Now I is equal to. So E1 by R1 plus E2 by R2. So you can bring this towards left side. How we will be getting? So VAB into 1 by R1 plus 1 by R2 plus. Correct? So now VAB 1 by R1 plus 1 by R2 is equal to E1 by R1 plus E2 by R2 minus I. Correct? Minus I. Now take LCM of R1 R2. So VAB R2 plus R1 by R1 R2. So E1 R2 plus E2 R1 by R1 R2 minus I. Correct? Now send this to right side. Now you can write VAB is equal to R1 R2 by R1 plus R2 into E1 R2 plus E2 R1 by R1 R2 minus I. So if you write final equation after multiplying this left side one, multiply this one with this one with this, then R1 R2 will be cancelled. So E1 R2 plus E2 R1 by R1 plus R2 minus I into what you will write? R1 R2 by R1 plus R2. Call it as equation number 3 R2. That is our wish. This is equation number 2. If you compare equation 2 and 3, VAB equal to E equivalent minus I into R equivalent. So R equivalent is this, E equivalent is this. Therefore, E equivalent is equal to E1 R2 plus E2 R1 by R1 plus R2. R equivalent is going to be equal to R1 R2 by R1 plus R2. So, this is the equivalent EMF formula when two cells connected in parallel, positive with positive. If they connect positive with negative, like this, if they connect R1, E1, E2, R2. Now, what is the effective EMF? What is the effective EMF means? E equivalent is E1 R2 minus E2 R1 by R1 plus R2. In between, minus you will get. R equivalent you will get same answer. If you connect two cells in parallel, two cells of same EMF, same internal resistance, identical cells connected in parallel, then what is the equivalent EMF? So E equivalent is, so ER plus ER by R plus R. So 2ER by 2R. So equivalent EMF is E. Now what is the equivalent internal resistance? R by 2. If two same cells connected, equivalent EMF always E, internal resistance R by 2. If three connected, E, you will get R by 3. Like that, if N cells connected like this, equivalent EMF E, equivalent internal resistance R by N. If N identical cells. So, if you observe one thing, if identical cells connected in parallel, equivalent EMF is that identical cell EMF. One EMF, how much? That is the answer. But internal resistance R by N. How many cells we are connecting? So that one we have to define. So this is about when cells connected in parallel, how to calculate effective EMF on this formula. Some people will write differently also, E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2. This is the equivalent EMF. This equation and this equation, both are going to be same. Here after taking LCM, we wrote this equation like this. This one also you can follow, no problem. Okay. I hope you people understood. Derivation is not required for you people, but why we derived means during this equation, sometimes during problems or while solving problems, you may require these equations. Therefore, we have derived. So please remember these final equations for solving problems. In next class, we will see when cells are connected in identical cells. When n identical cells connected in parallel with external resistance capital R and the grouping of cells, we will discuss. Thank you.